Using the law of sines, we need to show that in the triangle ABC that the given equation is true. Let us begin. First, we will specify the law of sines. Here we have a triangle ABC. This is an acute angle triangle, but the law of sines is going to work for an obtuse angle triangle or even a right angle triangle. For simplicity, I'm considering an acute angle triangle. So here, the letter A, B and C in lowercase represents the sides opposite to that of angle A, B and C respectively. Then the law of sine states that if we consider the side A, then we divide it by the sine of the angle opposite to it, which is angle A. This will be equals to the ratio of the side B to that of sine of the angle opposite to it. So that's angle B. And this is also equals to ratio of the third side, which is C, divided by the sine of the angle opposite to it, which is angle C. So this is known as the law of sines. Now, in order to solve our problem, what we'll do, we will suppose that these three constants are equals to a common constant, calling it 1 over lambda. Now, such that we can now represent sine of A as equals to A times lambda. Then sine of B, this will be equals to B times lambda, and sine of C will be equals to C times lambda. Fine. Now, coming to a problem, we'll start from the left hand side. So let's start with the left hand side. So here we have cosine squared B minus cosine squared C. But we know for a fact that cosine squared theta plus sine squared theta, so this is a standard identity with a value of 1. Now that means we can represent cosine squared theta as equals to 1 minus sine squared theta. Now in the case we have cosine squared B, so that will become 1 minus sine squared B minus cosine squared C, so that will become 1 minus sine squared C whole divided by B plus C. The reason why we converted the cosine function to the sine function, so that we can replace sine A, sine B, sine C with their respective values A lambda, B lambda and C lambda. Fine. Let's work with the second term as well. So we have cosine squared C, so that will become 1 minus sine squared C minus cosine squared A, which is 1 minus sine squared A divided by C plus A. And the third term is going to become, we have cosine squared A, which will be 1 minus sine squared A minus, we have cosine squared B, so that's 1 minus sine squared B whole divided by, we have A plus B in the denominator. Fine. Now, here 1 and 1 in the numerator gets cancelled, and we can rewrite the numerator portion as sine squared C minus sine squared B. Now the denominator, since addition is commutative, so B plus C can be also expressed as C plus B, plus the second term. So here we have sine squared A minus sine squared C whole divided by A plus C, plus the third term, which is B sine squared B minus sine squared A whole divided by B plus A. Now let's replace the value sine A, sine B, sine C with the respective value. So in the numerator, we're going to get lambda squared as the common factor. So we have C squared minus B squared whole divided by C plus B, plus lambda squared multiplied to A squared minus C squared divided by A plus C. And the third term will be lambda squared multiplied to B squared minus A squared whole divided by B plus A. Now C squared minus B squared over C plus B, so that's simply C minus B, plus lambda squared multiplied to, we have A squared minus C squared over A plus C, so that becomes A minus C. And finally, we have B squared minus C squared over B plus A, so that's simply B minus A. Now from each of the three terms, we are going to take lambda squared as the common factor, so that will get multiplied to C minus B plus A minus C plus B minus A. So we'll see that all the terms within the parentheses is going to get cancelled out, and we're left with lambda squared multiplied to 0, which is 0, and this is the expression on the right hand side. So using the law of sines, we have successfully showed that the given equation is true.